The flame-like patterns you have just seen were pictures of musical sounds. Similar patterns also are made of voice sounds. For the spoken word is, of course, the most important sound studied in telephone research. If my voice sounds familiar to you, it is probably because you have heard me on the Bell Systems radio program, The Telephone Hour. I'm Tom Shirley. Usually, I talk about the things telephone people are doing to serve you and your neighbors. Sometimes I tell about the research work done at the Bell Telephone Laboratories to help your telephone company make your service better and keep its cost to you as low as possible. So you can imagine that we of the Telephone Hour were much pleased when we got a call from one of the research men.
Well, there is a way you could help us besides telling about our work. We'd like to be present at one of your Telephone Hour rehearsals to make high-fidelity recordings of some of the instruments of the orchestra.
Any instrument in particular?
Say the harp, the cello, and the flute. We want to use them in our study of the characteristics of sound.
Sounds interesting. But tell me, why music?
Well, as you know, we carry the music of radio and television over the same telephone network that carries the telephone calls. But more important, the study of ways to transmit music has had a lot to do with the good telephone service we have today.
Okay. Why not come next Monday?
Fine. Then we'll be there at rehearsal next Monday afternoon.
Be looking for you. Goodbye.
Goodbye.
And so this film has been made to show you some of the research work going on to improve the telephone. And at the same time, we hope you will enjoy a brief glimpse of the Telephone Hour.
Would you like to jump down towards the end of the waltz?
Good. 10 measures before letter H, please. Quite good. Gentlemen, we have two scientists from the Bell Telephone Laboratories here at rehearsal with us today. They are doing research on the characteristics of different sounds, and they need some music samples. Are you all set in there, Wally?
Are you ready, gentlemen?
Yes, we are, Mr. McGill.
We're all set in here, Don.
Fine. Now, gentlemen, we'll need samples from the harp, the cello, and, oh yes, the flute. All right, you'll take your directions from the control room, please. Meanwhile, the rest of us will have a break.
All set? Take one, cello.
Good afternoon, Mr. Voorhees.
Hello, Mr. Franciscati. So glad to see you. How are you feeling?
Very fine, thank
Good.
you.
Just checking over the score of your first number, the Irish tune from County Derry. Looks very good, I believe.
Fine. I am ready anytime.
Oh, good.
Now we can call the orchestra back in about a minute. The only instrument we have left to record is the harp.
That was fine. Thank you all very much for your help. I think we got some good samples. Well, I think that's it, Mr. McGill.
Okay, that's fine. But don't leave yet. If you do, you'll miss one of the greatest violinists in the world, Zino Franciscati. He's our guest artist tonight on the Telephone Hour radio program.
that was really wonderful. I'm sure glad we stayed.
So am I. I wouldn't miss that for anything.
Yes, at the Bell Telephone Laboratories, scientists and engineers study spoken words, music, and many other kinds of sound so that you can hear more clearly and easily over your telephone. Here they are translating into visible patterns the music samples recorded at the telephone hour rehearsal. Any portion of that sound can be picked out and reproduced for better study in the form of the flame-like patterns. The music of the flute and of the cello are very different to the ear. Everyone knows the flute has a purer, more piercing tone. The flute sound has narrow energy peaks and few harmonics, while the cello sound is spread over a broad harmonic pattern. These wall charts are pictures of voice sounds. It is years of study of voices and music that have made possible the telephone service we have today. Let's consider for a moment the telephone in your own home. When you pick it up to make a call, you use it with confidence. You expect it to work properly. You expect to hear and to be heard clearly, naturally.
Hello, Dorothy. This is Margaret. I'm calling about...
But this didn't just happen.
Yes, it's going to...
Your telephone was designed and built, you might say tailor-made, to respond faithfully to the harmonic patterns of your voice. Years of research in sound have produced the telephone instrument. Endless tests have been made to be sure that the transmitter and receiver, their very shape and size, will have uniform response to all frequencies in the fluctuating valleys and peaks of speech. The very heart of these studies is this small condenser microphone. It is the measuring unit that accurately records the slightest sound. It never changes, regardless of temperature or humidity. It makes possible the delicate measurements that tell the scientist the effect of the changes he has made. This tiny microphone came out of research in devices to reproduce faithfully speech and music. This same measuring unit is used at the plants of Western Electric to test every telephone instrument before it is placed in service. If the moving dot on the screen follows a path like this, the handset is performing properly. Your telephone passed this exacting test to ensure that it would faithfully reproduce your voice. But important as it is, the work in sound research is only a part of the Bell Telephone Laboratories' job of making your telephone service ever better and of greater value to you. Other scientists work constantly on the telephone instrument itself, seeking ways to make it more efficient, more durable, and easier to use. The instrumentation laboratory is equipped with all the necessary measuring and analyzing devices, because research is essentially measurement, often incredibly fine measurement. It is in this way that telephone research charts its path as it moves ahead. With this equipment, impurities in materials on the order of 1 part in a billion may be detected. Such extreme precision is necessary in many fields. It was necessary in the development of a new refining technique for germanium, in which the molecules of the metal are actually rearranged. This is germanium, the metal that made possible the Bell Telephone Laboratories' great development, the transistor, the most important invention in electronics since the vacuum tube. A new device that can do many of the jobs done by the vacuum tube and many the tube can't do. As to wires and cables, They are giving better and more economical telephone service because telephone scientists and engineers have found ways to send many conversations over the same pair of wires at the same time. Here is one type of coaxial cable. As many as 1,800 telephone conversations can be sent at the same time over a pair of coaxial tubes like these. Or a pair of tubes can carry 600 telephone conversations as well as 2 television programs. Exploration in still another field, microwaves, paved the way for another method of communication, radio relay. Telephone research is thus constantly finding new ways to make your telephone service better, to bring to you the voices of friends, the pictures of television, and the music of radio. So that's our story. We hope you enjoyed the music. And equally important, we hope we have helped you to understand more about the work of the telephone scientists in making it possible for you to talk around the world or across the street.